LCM. Let me repeat all the important models. LCM stands for least common multiple. Least common multiples. The methods which we discussed are method 1, LCM of 6, 12 method. Method 2, if the number is not a multiple of other numbers, LCM of 9, 12 method. Method 3, co-prime concept. Co-prime concept. Method 4, not a co-prime concept. Not a co-prime concept. Not a co-prime concept. Method 5, condensing method. Condensing method, which is derived from method 1 and method 2. Method 6, highest powers method. Highest powers method. Highest powers method. These are the various methods that we discussed. Right? Now, let us get into the problems. Anil Nair's way of solving answer options. What are the important methods that we discussed? Concept. If one number has a digital sum 9, if one number has a digital sum 9, LCM of any number with a digital sum 9, answer digital sum should be 9. Answer digital sum should be 9. First one. Second one, divisibility rule concept. If more than one answer option has the same digital sum, use divisibility rule concept. These three, divisibility rule concept. I hope it is clear. Divisibility rule concept. Right. Now first problem. First one. Now before that one, LCM of fractions. LCM of fractions. It is LCM of numerator divided by HCF of denominator. HCF of denominator. I will give you the proof also. HCF of fractions. HCF of fractions. It is HCF of numerator. HCF of numerator divided by LCM of denominator. LCM of denominator. First time you are going to see the proof. Why LCM of fractions is LCM of numerator by HCF of denominator. Any one proof I will do it. I will do this proof. I will do this proof. Let there are three fractions, x by y, a by p, m by n. Let there are three fractions, x by y, a by b and m by n. I am finding HCF of all this. Let HCF of all these is p by q. Right? Why HCF of fractions is HCF of numerator by LCM of denominator. Now, let me take a simple example. I am doing HCF because it's relatively easy to do. 6, 12 and 9. HCF of 6, 12 and 9 is 3. HCF of 6, 12, 9 is 3. That means, can I say, by taking this an example, 6 is a factor of 3 or 6 is a multiple of 3. 6 is a multiple of 3. Am I right? 6 is a multiple of 3. Or in other words, 3 is a factor of 6. 3 is a factor of 6. That means remainder when 6 divided by 3 is 0. Am I right? 6 divided by 3, it is 0. Listen carefully, sir. Otherwise you will mug up. Why LCM of HCF of fractions is HCF of numerator by denominator? Proof. HCF of 6, 12 and 9 is 3. That means 6 is a multiple of 3. 6 is a multiple of 3 means 6 when divided by 3, remainder is 0. According to this example, x by y by p by q, remainder should be 0. That means remainder of x by y into q by p, it should be 0. It should be 0. Are you all with me? It should be 0. What is the conclusion from this one? Conclusion is, if x by y into q by p is 0, that means x should be a multiple of p. X should be a multiple of p and q should be a multiple of y. Am I right? Q should be a multiple of y. Now if you observe, x should be a multiple of p or q should be a multiple of y. Q is a multiple of y. Similarly, next conclusion is q is a multiple of b. Then q is a multiple of n. If q is a multiple of y, b and n, obviously I will take LCM of the denominator. Are you all with me? Just let us take only one thing, where q is a multiple of y. Again I am explaining. HCF of 6, 12 and 9 is 3. That means 6 is a multiple of 3. If 6 is a multiple of 3, 6 when divided by 3, remainder is 0. Taking this example, can I say that if I write 6 as 6 by 1, x by y when divided by p by q is 0. That means x by y into q by p is 0. That means q should be a multiple of y. Am I right? Q should be a multiple of y. If q is a multiple of y, next condition q is a multiple of b. Next condition q is a multiple of n. Q is a multiple of y, b and n. That means multiple I should take, so I wrote LCM down. Are you all with me? Are you all with me? Why the denominator should be LCM? Why can't it be HCF? It cannot be HCF in the denominator. Why? Because if 6, 12, 9 HCF is 3, 6 divided by 3, remainder is 0. X by y by p by q is 0. X by y into q by p is 0. Q should be a multiple of y. Why? Because x and y are co-primes in a fractions. If q is a multiple of y, if q is a multiple of b, if q is a multiple of n, all the three numbers common multiple is nothing but LCM. I hope it is clear, right? I hope it is clear. That is the reason we will write LCM of fractions is LCM of fractions is LCM of numerator divided by HCF of denominator. So it is LCM of 8 by 1, 16 by 20 and 10 by 7. These are nothing but LCM of 8, 16 with 10 divided by HCF of 1, 20 and 7. HCF of 1 with any number 1. 8 is a factor of 16. It is eliminated. 10 and 16. 10 and 16. LCM is 2 5s are 2 8s are. So this will become 2 into 8 5s are 40. Answer is 80 by 1, which is 80. LCM of fractions is LCM of numerator by HCF of denominator. Very easy question. I don't need to spend too much time on this. Next onwards, every question is a beautiful question. Find the LCM of pi and 22 by 7. Pi is an irrational number. Pi is an irrational number. 22 by 7 is a rational number. Pi is not equivalent to 22 by 7. Pi is approximated to 22 by 7. Approximation cannot be the value. LCM for natural numbers exists. LCM for natural numbers you can find it out. LCM for rational numbers you can find it out. Rational numbers you can find it out. Rational numbers is fractions. If the denominator is 1, then it becomes a natural number. Irrational with rational cannot exist. Irrational with rational, we cannot find out LCM. Cannot find out LCM. Sir, why we cannot find out LCM? Or LCM do not exist. LCM do not exist. LCM for a rational with irrational cannot be possible. Why? Because rational is a terminating decimal. Rational is a terminating decimal. Irrational is a non-terminating decimal. Non-terminating decimal. First reason. Rational is a recurring decimal. The value will keep on moving. That's irrational is a non-recurring decimal. Irrational is a non-recurring decimal. It's completely opposite poles. Irrational with rational, you cannot define LCM because one value will stop, another value will keep growing. You cannot compare a unique value with a countable infinite value. You can compare two terminating values. You cannot compare a non-terminating non-recurring with terminating recurring. Non-terminating non-recurring, right? With things. Irrational with rational, it is not possible. I hope it is clear. Second one. Now, third one. Listen carefully, sir. LCM model 2. Model 2. Beautiful questions today. You will fall in love with the kind of questions that you are going to solve. Mark my words. Now, 6 power 6 is, write the number as a power of prime basis. 2 into 3 power 6, which is 2 power 6 into 3 power 6. 8 power 8 is 2 cube power 8, which is 2 power 24. We don't know the value of n, but we know the value as 12 power 12. 12 is nothing but 2 square into 3 power 12, which is 2 power 24 into 3 power 12. LCM always takes the highest power of the given prime basis. LCM always takes the highest power of the given prime basis. LCM always takes the highest power of the given prime basis. Now see here. Answer contains 2 power 24. This answer is nothing but the highest power. That means this highest power should be one among the three numbers. It is not 2 power 24. It is 2 power 24. So n will take any value from 0 to 24. Why? Because 2 power 6, 2 power 24, 2 power 0. What is highest? 24. 2 power 6, 2 power 24, 2 power 1. What is highest? 24. 2 power 6, 2 power 24, 2 power 24. What is highest? Again 24. Because the highest is there in the second value, third value can take anything from 0 to 24. Next prime base is 3 power 12. 3 power 12 is not present in the first number, not present in the second number. Third number it is present. Into 3 power 12. 2 power 0 to 24 into 3 power 12. I hope the idea is clear. So, what are all the values it will take? This will take all the values from 2 power 0 into 3 power 12 to 2 power 24 into 3 power 12. 0 to 24, 25 values it will take. A very good question. Generally in your textbooks you have read 3 numbers are given, LCM we have to find out. Now I am doing the reverse of this. LCM is given, one number, how many values it can take. A beautiful understanding of the definition that LCM always takes the highest power of the given prime bases. Those students who want a recap, please listen carefully. 6 power 6 is 2 into 3 power 6. 2 power 6 into 3 power 6. 8 is 2 power 3 power 8 is 2 power 24. Because the second number contains 2 power 24, third number is taking from 0 to 24. If the second number does not have 2 power 24, only 2 power 24 is given to the third number. I hope it is clear. 0 to 24, total 25 values it will take. Total 25 values it will take. Very good question. We will do 2 more problems of these model 2. Extremely important. 3 numbers are there. LCM is given. 2 values are given. Third value we have to determine. Next. See the second question. What is the smallest positive integer? N such that LCM of n comma 30 is nothing but 180. LCM of n comma 30, it is 180. 30, write down it as prime bases. 2 into 3 into 5. Is it clear? N, we don't know. 180, write down it as 180, it is 2 90s are, 2 45s are, 3 15s are, 3 5s are. So this is 2 square into 3 square into 5 power 1. 2 square into 3 square into 5 power 1. Now what is the definition of LCM? LCM always takes the highest power of the given prime bases. LCM always takes the highest power of the given prime bases. Answer is 2 square. This is 2 power 1. So definitely it should be 2 square. Answer is 3 square. But it is 3 power 1. Definitely it should be 3 power 2. Answer is 5 power 1. It is already 5 power 1. So it can take from 5 power 0 or 5 power 1. So 2 cases. 2 square into 3 square into 5 power 0 or 2 square into 3 square into 5 power 1. Totally how many values n can take? 2 values. But it is smallest positive integer. If it is smallest positive integer, this case is eliminated. 4 9s are 36. 36 ones are 36. 36 ones are 36. Idea clear, right? Haritha, we are taking 0 to 24. Why? Because one number has got 2 power 24. I will do third question so that it will be clear to you. Third question, it will be clear to you. None of these quality problems you will see it in any live class. Some questions, a random question can be solved. I am interested in making this class public. If I get 1000 plus watching before the class is over, it will take 2 seconds for you to click on the share button and tell it to your friend who is struggling in aptitude, to share it and say, watch this content and maximize your score. Your 5 seconds job, each one of you do it. The minute I get 1000 plus watching, today all the live classes I will make it public. A commitment is a commitment from my end, because the only way which I can get motivated, instead of sitting in home and telling to everybody that I cannot go out, me and my team are slogging in office. We are sleeping in office. My team is preparing PPTs for you. The LCM of, one more, third question. LCM of 12 power 12, 256 power 9 and x is 24 power 24. How many integral values x will take? Let us see. Same step by step. 12 power 12 is 2 square into 3 power 12, which is 2 power 24 into 3 power 12. 256 power 9 is 2 power 8 power 9, which is 2 power 72. X I don't know. 24 power 24 is 2 cube into 3 power 24. Haritha, listen carefully, you will understand it here. It is 2 power 72 into 3 power 24. Now see here, it is 2 power 72. 2 power 72, check whether it is present in any of these three numbers. Not present here. Entire 2 power 72 is present. So x can take any value from 0 to 72. 3 power 24, not present in the first. Second, it should be not present. Second, it is not present. Third, definitely it should be present. So 2 power 0 into 3 power 24 till 2 power 72 into 3 power 24. 0 to 72 is 73 values. Is it clear? Model 2, 3 examples. First 120 natural numbers. Already we did this. LCM of first 120 natural numbers. LCM of first 125 natural numbers. This is kx. This is kx. Already we did this in our first class. Find k. What is the shortcut I discussed? After 120, what are all the natural numbers that are present? 121, 122, 123, 124, 125. Identify the numbers. Identify the numbers which are of the form p power k. Identify the numbers which are of the form p power k. P is a prime number. Morning we discussed, afternoon we discussed 2 into 61, 3 into 41, 4 into 31. This is 11 square 121. This is 5 cube 125. What is the highest power of 11 till 121? 11 power 1 is 11. 11 square is 121. So extra one more 11 you will get. 5 square is 25. 5 cube is 125. Extra 5 I will get. So the K value is 55. For one time, you want to listen to it again, then you have to reach that number 55. Again I am explaining. After 120, what are all the natural numbers? 121, 122, 123, 125, 125. 121 is 11 square. 125 is 5 cube. Power of 11 till 120 is only 1, highest power. So extra 11 will come. 5 square is 25. 5 cube is 125. Extra 5 will come. 11 into 5 is 55. Clear, right? One more. LCM. I hope Shiva right now you are understanding. LCM of, directly you will say 85 natural numbers. 78, 79, 80, 81, 82, 83, 84, 85. 85. We should identify the numbers. Identify the numbers which are of the form p power k, where p is a prime number. 78 is 2 into 13, 2 into 40, 2 into 41, 4 into 21, 85. 79 is 79 power 1 as it is. 81 is 3 power 4. Highest power of 3 till 77. 3 cube is 27. So extra 3 will come. These over. 83 is another prime number. 79 into 3 into 83. This is the answer. Just by looking at the numbers, you will determine what is the concept in this. Identify the numbers which are of the form. Identify the numbers which are of the form p power k. P power k. 79 into 3 into 83. Model 3. These also we discussed. Model 3 also over. Model 4. Model 3. I think already we discussed. Both are equal. First class we discussed. LCM of 1, 2, 3 till 10 is equivalent to LCM of 7, 8, 9, 10. Both are equal. We have discussed Y also. Right? In case if you miss the previous session, you may find this session little difficult. Now, I kept this question because so many students have asked me to repeat it in the WhatsApp. LCM of 1, 2, 3 till 200 divided by 105, 107 till 200. LCM of 1, 2, 3 till 200. What is the highest power of 2 till 200? 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. So it is 2 power 7. Highest power of 3. 3 power 4 is 81. 3 power 5 is 243. 3 power 4. 5 cube. 7 square. 11 square is 121. 13 square is 169. 17 square. All are remaining and so on up to 199 power 1. 199 power 1. All are prime numbers divided by 2 divided by and so on up to in between here 101 power 1 will come. 103 power 1 will come. 107 power 1 will come. and so on, and so on. I hope it is clear, right? Any LCM can be written as the highest power of the prime number. 2 power 7, 128, 3 power 4, 81, 5 cube 125, and so on up to 101 power 1 till 199 power 1. Divided by highest power of 2, 128, it is present in this set. Highest power of 3, 8, 3 power 4, 81, 81, 81, if you see, in this set there is a number known as 162. 162 is 81 into 2. So 3 power 4 will come. 5 cube 125 is there. Everything will come except these two numbers, because it is starting with 105. So what is missing? 101 into 103. 101 into 103. 101 is missing, 103 is missing. Any doubts, ask me. Please tell this answer. Just look at it and say the answer. Say this answer. Don't use pen. You are my students. My students has to be extremely sharp. Now tell me, what are all the values will come? Which values will come? Mention the answer. Write the answer. LCM of 1, 2, 3 till 100. 2 power 6, 64. 3 power 4. 5 square. 5 square. 25. 7 square. 49. And so on. Up to 53. Remaining is 59 power 1, and so on up to 97 power 1, divided by 2 power 6, 64, it will come, 3 power 4, 81, it will come, 5 square 25, it will come, till 97 power 1. What is missing? 53 is missing. 51 is not a prime number. It is a composite number, so it is eliminated. 51 is 3 into 17. 51 is 3 into 17. 51 is 3 into 17. Aishwarya, the doubt which you asked, 51 is a composite number, be careful. 51 is a composite number.